Solving quadratic equations by factoring. So let's recall what exactly is a quadratic equation. Quadratic equation is of the form ax squared plus bx plus c equals 0. Now here comes the new part. The zero product property states if a times b equals 0, if and only if a equals 0 or b equals 0. Well, what exactly does that mean? In other words, if two values are multiplying and the result is 0, then one of the values must be 0 in disguise. So let's kind of explore with that. Would 5 times 3 ever equal 0? Would 5 times negative 8 ever equal 0? So what times 5 would make it equal 0? The number must be 0. What if we had negative 2 times negative 7? Would that ever equal 0? What about 6 times negative 7? Would that equal 0? So what times negative 7 would equal 0? Well, the number must be 0. Example 1, solve. So for example 1a, we have a minus 5 times a plus 2 equals 0. So look at it this way. A minus 5 is some number. A plus 2 is some number. So what we really have is some number times some number that equals 0, which means one of these numbers must be 0. If we look at the first number, a minus 5 equals 0. What if that is 0 in disguise? Or the other number, a plus 2, could be 0 in disguise. So what we have are two mini equations. Well, let's solve these two equations. Looking back at the first, a minus 5 equals 0. To get a by itself, we need to add 5 on both sides, which gives you a equals 5. Now looking at the second equation. To solve for a, we need to undo adding, which means we subtract 2 on both sides, which gives you a equals negative 2. So what we appear to have are two solutions, but let's take the time to check. If I plug a 5 back into the original equation, it becomes 5 minus 5 times 5 plus 2 equals 0. Well, 5 minus 5 is 0, and 5 plus 2 is 7, but you notice 0 times 7 is what? 0. And so it is a true statement. 0 does equal 0. So that solution works. Let's do the same thing, but this time for the other solution of a equals negative 2. We go back to the original equation, plug in a negative 2. When we simplify the parentheses, we get a negative 7 times 0. And negative 7 times 0 is 0, and which is a true statement because 0 does equal 0. So therefore, we have our two solutions. Example 1b. We have 3t plus 1 times t minus 7 equals 0. So again, look at this as some number, and this is some number. And so we do have it of the form some number times some number equals 0, which means one of those numbers has to be 0 in disguise. So the first number, we pull it aside and we write it as 3t plus 1 equals 0. Or we take the second number, t minus 7, and set that equal to 0. Now we have our two mini equations, and now it's time to solve. Looking at the first equation of 3t plus 1 equals 0, to help solve for t, we need to get rid of adding 1. So therefore, we need to subtract 1 on both sides, which gives you 3t equals negative 1. Now, notice the 3 is touching the t. That means multiplication. How do you undo multiplication? We divide, but what you do on one side, you must do to the other. And so 3t divided by 3 reduces to t, and your solution appears to be negative 1/3. Now looking at your second equation, t minus 7 equals 0, we need to solve for t. To do that, we need to add 7 to both sides, and we find t equals 7. And there are your two solutions. You could take the time now to check your answers to guarantee that you are correct. Example 1c, 5m times 2m minus 9 equals 0. This one may look a little different, but if you noticed, 5m is counted as a number, a value, and 2m minus 9 is also a number. And so this is still of the form some number times some number equals 0. So the steps are still the same. We take the first value, set it equal to 0. We take the second value, set it equal to 0. Now we have our two equations, and we're ready to solve. Looking at the first equation, to solve for m, we need to divide both sides by 5, which gives you m equals 0. The second equation, 2m minus 9 equals 0. To solve for m, we need to add 9 to both sides, which gives you 2m equals 9. Then we need to divide both sides by 2 so we can get m all by itself. So therefore m equals 9 over 2. And there are your two solutions. Again, this would be a good time for you to check your answers by plugging them back into the original equation. Here is your try it problem. 2y minus 5 times y plus 6 equals 0. Okay, let's see how we did. Notice we have some number times some number, and it equals 0. So to solve, we take each value and set it equal to 0. Looking at the first equation, to help solve for y, you should have added 5 to both sides, which gave you the equation 2y equals 5. Then divide both sides by 2, which gave you y equals 5 halves. For your second equation, to solve for y, you should have subtracted 6 on both sides, which gave you y equals negative 6, and those are your two solutions. Do you think the problems will always appear so nice and neat? Of course not. Where would the challenge be in that? Looking at the previous examples, what did you notice? All equations equaled what? They all equaled 0. All the equations were in what form? They were all in factored form. And then each piece or factor was set to 0 and then solved, creating the mini equation. So these are the steps we're going to be following to solve all equations of this format. Looking at example 2, the direction says to solve. And so for part A, we have x squared minus 3x equals 28. Now our steps are up in the corner of the screen. The first one says all equations equaled 0. Look at your equation. Does it equal 0? No, it equals 28. So we need to get rid of that 28, which means we need to subtract both the left and the right side by 28, which gives you x squared minus 3x minus 28 equals 0. Now that it equals 0, we've done the first step. Now it says it has to be in factored form. Is this factored? No, which means we need to do some side work literally on the side of your paper. So we're looking at the quadratic part only, the x squared minus 3x minus 28. First, for factoring, we always check and see, do they have anything in common? And if you notice, they do not. So the other thing we notice is we have 3 terms, and when you have 3 terms, you do the AC method, meaning you take your first coefficient and your last value, your constant, and you multiply them. So 1 times negative 28 gives you negative 28. Now we come up with our list of multiples. 1 times 28, 2 times 14, 3 doesn't work, and 4 and 7. And now we decide if we need to add or subtract. Well, look at the sign, and that means we will subtract to equal the middle number. And in this case, our middle coefficient is -3. So looking from your list, what two values could possibly subtract to give you -3? And that would be 4 and 7. So now we need to force our 3 terms into 4 terms by expanding the middle term. And because we need it to be a -3, that means we're going to have a positive 4x and a negative 7x. So we now have 4 terms, we split it in the middle, and now we factor by grouping. Looking at the first 2 terms, what do they have in common? They both have an x, so if we factor out an x, it leaves you with x plus 4. Looking at the last 2 terms, negative 7x minus 28, we need to see what they have in common. And they both have a 7, and because the leading term is a negative, we will factor out a -7 from both terms. Now remember, to factor out means to divide both terms by -7. And when you do, that leaves you with x plus 4. Now we look at our expression as a whole. Do we see anything in common? And you should. You should notice x plus 4 is in both parts. So we factor x plus 4 out, which leaves you with x minus 7. We have now factored that quadratic. Since we're done with our side work, we go back to the equation and write it in factored form. So now our equation is x plus 4 times x minus 7 equals 0. We now have the equation in factored form. So now we notice we have some number, x plus 4 equals 0, and some number, x minus 7 equals 0. We're now setting each piece equal to 0 and solving. To solve for x, we subtract 4 on both sides, which gives you x equals -4. For the second equation, we need to add 7 on both sides, which gives you x equals 7. And those would be your 2 solutions. Could you go back and check? Absolutely. Plug these back into the original equation. Example 2b, y times 12y minus 5 equals 2. Well, the first thing is you probably want to distribute, which would give you 12y squared minus 5y. Now remember those steps. We said our equation has to equal what? 0. And so notice our equation does not equal 0, so we need to subtract 2 on both sides, which now gives us 12y squared minus 5y minus 2 equals 0. Now that our equation equals 0, we need to see if it's in factored form. And notice it is not in factored form, so on the side of our paper, we're going to factor the quadratic. We have 12y squared minus 5y minus 2. We always look for a GCF first, but in this case they do not have one. So we move on to the AC method. We take the first number times the last number, which creates our value of -24. From here, create a list of multiples. 1 times 24, 2 times 12, 3 times 8, 4 times 6, and 5 doesn't work. So there's your list. Now to decide if we add or subtract, we look at the leading sign. Because it's a negative, that means we will subtract to equal the middle term. And in this case, the middle term is -5. So look through the list and find the combination that would give you, when subtracting, a -5. And it would be the 3 and the 8. So we need to expand the middle term and make it no longer 3 terms, but 4 terms. Now that we have 4 terms, cut it in half, and we factor by grouping. Looking at the first 2 terms, they both have a 3y in common, and if we factor or divide both terms by 3y, it leaves you with 4y plus 1. Looking at the last 2 terms, they have a common factor of a -2. So if we factor out a -2, that leaves us with 4y plus 1. Notice 4y plus 1 appears in both parts, so that is your common factor. And if we factor out 4y plus 1, that leaves you with 3y minus 2. We have now factored it, so now we put it back into an equation. 4y plus 1 times 3y minus 2 equals 0. From here, since we have some number times some number equals 0, we take each individual piece and set it equal to 0. So to solve the first one, we subtract 1 on both sides, then divide both sides by 4, and we find y equals -1/4. For the second equation, we add 2 to both sides, divide both sides by 3, and we find y equals 2/3. And those are your two solutions. Example 2c, 3x squared minus 18 equals 3x. Again, first step, does your equation equal 0? No. So we need to get rid of that 3x. To do that, we subtract 3x on both sides, and we notice it needs to be in the correct order. So the correct order would be 3x squared minus 3x minus 18 equals 0. Now that our equation equals 0, we need to see if it's in factored form. And it is not. So on the side of your paper, we are going to factor. Looking at 3x squared minus 3x minus 18, the first thing we always look for factoring is a GCF. Do these have anything in common? They do. Notice each of the terms are divisible by 3. So we are going to factor out a 3, which leaves us with x squared minus x minus 6 remaining. We're focusing on the part within the parentheses, which now we're going to move on to our a times c, which is 1 times -6, which gives you -6. We create our list of multiples. It's a very short list. And then we decide, are we going to add or subtract? And because of the sign, we will subtract, and it has to equal the middle number. So it has to subtract to give you -1. From our list, that would give us 2 and 3. So we will expand the middle term. Now notice that 3 on the outside is still there. It is a tag along. Although we're focusing on the inside, the 3 is still on the outside. So looking at our 4 terms on the inside, we still split it in the middle, and we factor the first 2 terms. Notice both terms in the front have an x in common, which would leave you with x plus 2. The last 2 terms have a -3 in common, so if you factor that out, that leaves you with an x plus 2. Now again, we still have that 3 on the outside, but on the inside, what do you notice is common? The x plus 2, which would leave you with x minus 3. Now that we have this factored, we take this back into the equation. The 3 is on the outside, we have the x plus 2, and we have the x minus 3. So now we have some number times some number times some number equals 0. So we take each number and set it equal to what? 0. So because we have 3 numbers multiplying, we have 3 different pieces. Now let's start looking at the first one. 3 equals 0. Is that possible? It's not possible. 3 will never be 0, so we X that out and disregard. Now we look at our second equation. X plus 2 equals 0. To solve for x, we subtract 2 on both sides, and we find x equals -2. For your third equation, x minus 3 equals 0. To solve for x, we add 3 on both sides, and so we have our 2 solutions.